In the previous module, we saw that while our two data files have the same granularity, they are in different formats. Historical minimum wage has a row for wage by jurisdiction and year, while the historical GDP has a row for GDP by year with a column for each jurisdiction. We will need to transform our GDP data by melting the data frame. This has nothing to do with the Wicked Witch of the West. This is a technique we can use to convert wide data frames into tall data frames. So we want to transform our GDP data from a wide format to a tall format. The table on the right is an example of what we want to eventually have. One column for date, one column for jurisdiction, one column for GDP. Turns out that Pandas has a built-in function called melt, which will allow us to convert each pair of date and jurisdiction into its own row. How do we do that? We tell Pandas, here is the list of our identifier columns, in other words, the date, and here's a list of the columns that have our values. In our case, we have one identifier column, our reference period, and our values are stored in all of the other columns. So we will need to provide the melt function with two values, the ID variable names and the value variable names. For our first example, we're going to ask Pandas to produce a melted data frame which has GDP for Ontario and for Canada by year. First, we specify our list of ID variable names, reference period. Then we specify which columns have our values, which columns we want to melt down into a row, into a combination of rows. And then finally, we melt down our GDP data frame by calling gdp.melt and specify the ID values and the value values. Let's try this. We'll come back into Spyder. We'll close our data frames. We'll say ID var names equals reference period. And then value var names equals Canada and Ontario. Finally, I'll create a variable called GDP melt equal gdp.melt ID vars equal to ID var names. Value vars is value var names. And if we look, we get an error. ID vars are not present in the data frame, reference period. Well, what's going on here? Well, I've probably misspelled a column name. Let's print out the list of columns by doing print gdp.columns. And if I scroll up in my list, you can see that I've specified reference period with a capital P. It should be a lowercase p. Now, I run this code and look at that. I have a row for each combination of year and jurisdiction. 2009 Canada, 2010 Canada. If I scroll down, 2009 Ontario, 2010 Ontario. So now we have a melted data frame, but we only have data for Canada and Ontario. We want to have all of the provinces and territories included. Now we could fill in the rest of value var names manually, so we could type out each province, right? But this is a bit prone to error. Remember from week 4 that we could get a list of our columns by name and then drop our columns by index using list slicing? So we can use the same technique to get a list of jurisdiction names. How do we do this? So if we run the following code, we will get all of the column names from our GDP data frame. Now, if we put square brackets after gdp.columns, we can filter our list of columns. And remember that the lists always start at index 0. So our first column name is called reference period. Our second column name is called Canada. Our third column name is Newfoundland and Labrador. This is where we want to start, our third column. So how could we slice this list? Well, we can specify a range of columns to return by using the colon and column indexes. So this is similar to what we did with string slicing. For example, if I do gdp.columns, square bracket, 1, colon, and then n square bracket, that says to Python, give me all the column names except for the very first column, the column at index 0. Now let's say I wanted Quebec, Ontario, Manitoba, and Saskatchewan's data. Take a look at their indexes and take a look at this slicing method we're using. What values should I fill in for the left-hand side of the colon and the right-hand side of the colon? Pause the video and give it a try. So if we only want Quebec, Ontario, Manitoba, and Saskatchewan, we would use the following slice, 6, colon, 10. Because that tells Python, give me the column names from indexes 6 through 9, excluding index 10. Remember that the number after the colon is excluded from the result. Finally, say we wanted Nova Scotia, Manitoba, and Yukon's data. We could get clever with our slice. We could pass a list of column indexes in this case because our range of columns is not continuous. So these are a couple of different strategies for fetching different columns from your data frame. So if we want to get the GDP for, say, just the provinces or for Canada and all of the provinces, we would write the following code. We would get our value var names by doing gdp.columns, starting at index 1 and going to the end. Let's try writing this code. I'm going to replace value var names with gdp.columns, starting at index 1 and going to the end. And if I run this code and I look at GDP melt, I have 126 rows, 3 columns, reference period, variable, value. Reference period, variable, value. And I have this for all of my provinces and territories. So now we have 2 data files which have the same granularity. In the next video, we're going to join our data files together.